JWST just detected light from 3I Atlas that, by every rule of astrophysics we know, shouldn't exist.
I can see like how the solar system comets behave, but I never saw a comet spinning.
It wasn't supposed to be there. It wasn't predicted. It wasn't modeled. And yet, there it was. A faint, narrowband signal that left astronomers staring at their screens wondering if they were looking at a glitch, a reflection, or the first real clue that 3I/Atlas is far stranger than anyone imagined.
The James Webb Space Telescope spotted a large object about 10 light-years away moving toward Earth. The posts claim that the telescope captured the object changing its trajectory.
When the James Webb Space Telescope was first directed toward the interstellar object, expectations were modest. JWST can pull signals out of darkness better than anything humanity has ever built, but 3I/Atlas is faint, fast, and already slipping into the outer haze of observability.
It's moving too quickly to have come from the outer reaches. It's from someplace else.
Still, Webb's infrared instruments can detect heat signatures and reflected solar radiation far too subtle for ground telescopes. But what Webb found wasn't subtle, it was contradictory. The telescope registered a spike in a wavelength region where 3I/Atlas should be almost completely dark. Based on the object's estimated composition, dusty, carbon-rich, and colder than Pluto, there should have been no meaningful emission or reflection in that band. Yet JWST picked up a clean, narrow, almost laser-like line. Not bright enough to suggest artificial origin, but too clean to fit ordinary reflection. Something was producing or amplifying light in a spectrum the object physically shouldn't interact with. Astronomers immediately suspected an error. Maybe a cosmic ray strike on the detector. Maybe contamination from a background galaxy. Maybe internal sensor noise. JWST's team reviewed the raw telemetry, calibration frames, background subtraction, and noise maps. But the signal held. It didn't appear in control frames. It didn't match cosmic ray patterns. And crucially, it appeared again on the second observation sweep, hours later, after the telescope repositioned.
Let's just hope that it will not send any unwanted gifts to Earth.
Same frequency range, same narrow emission, same source coordinates. This changed the conversation instantly. If the detection wasn't a glitch, then the implication was unavoidable. 3I/Atlas was emitting, or reflecting, light in a way we do not understand.
We want to have this press conference to share it with the world, to share it with you. And also, we are ultra transparent, right? If we had this exciting news about the peer reviewers and what we think we found at NASA, and I didn't bring it to you.
The most immediate natural explanation involves fluorescence, where certain molecules absorb higher energy radiation and re-emit it at specific wavelengths. But for that to happen, 3I/Atlas would need surface compounds capable of fluorescent re-emission, and nothing in its earlier spectral data hinted at this property. No polycyclic aromatic hydrocarbons. No exotic organics. No ice is known for photoluminescence. Even stranger, the wavelength Webb detected is associated with ionized particles, something that requires energy input the object shouldn't be receiving. Another possibility is that 3I/Atlas has a thin transient atmosphere generated by sublimation, and that charged particles are interacting with sunlight to create narrowband emissions. But again, the object has shown no extended coma, no off-gassing signature, no thermal spikes. Every previous observation suggested a dark, inert, cold traveler. The new signal flips that assumption upside down. Some astronomers believe the object may contain materials not common in our solar system. Interstellar grains formed around a dying star, rich in metals or compounds rare to us. If these materials have unusual optical properties, they might scatter or re-emit light in unexpected ways. But that leads to another question. Why at such a consistent, stable wavelength? Why so narrow? Random materials don't create such precise lines unless they're part of a highly selective physical process. Then there's the theory no one wants to say out loud, but everyone knows is lurking in the background: coherent emission. Not necessarily artificial, but some form of natural but extremely rare physical phenomenon where aligned crystal lattices or magnetic structures amplify photons in a single direction. This would be extraordinary. Nothing like that has ever been observed in comets or asteroids. But interstellar space is vast. The environments that formed 3I/Atlas may be radically different from those that built our solar system. Yet another possibility is that the light isn't coming from the surface at all, but from within. Internal voids filled with volatiles could create resonance chambers when struck by solar radiation, emitting harmonics. If so, we may be looking at an interstellar object with a hollow or semi-hollow interior, which is itself extremely unusual. No known natural object of this size retains large internal cavities. Some researchers explored the idea that magnetically induced emission might be involved. If 3I/Atlas has a remnant magnetic field or interacts with the solar wind in an extreme way, plasma processes could generate sharp spectral lines. But this would also require the object to possess metallic elements in specific distributions or be interacting with charged particles far more strongly than expected. There's also the peculiar fact that the emission seems to flicker in a pattern, not regular enough to call pulsed, not random enough to be noise. It rises and falls like something modulating, a breath-like rhythm, though slower and subtler. This could be rotation, but the timing doesn't match earlier measurements of the object's light curve. So is the object tumbling differently? Did Webb catch it at a strange angle? Or is something else affecting the brightness? The biggest mystery is the energy source. If 3I/Atlas is emitting light, where is the energy coming from? It's too far from the sun for typical heating. It's too cold for thermal processes. And the emission spectrum doesn't match reflected sunlight. It's like the object is taking an energy from somewhere and releasing it in a way that defies the simple models astronomers use to track interstellar bodies. A few independent researchers have raised the comparison no one can ignore. Oumuamua, the first known interstellar visitor, also emitted anomalous signals. Not this frequency, not this pattern, but light curves and accelerations that couldn't be completely explained by known physics. Many concluded it was some kind of porous nitrogen iceberg or fractal dust aggregate. Others argued for non-gravitational acceleration mechanisms, but nothing ever fit perfectly. Now, with 3I/Atlas showing its own set of impossible signals, the statistical coincidence begins to collapse. 2 out of 3 known interstellar visitors behaving strangely suggests a pattern. A pattern that hints that materials formed outside the solar system may behave very differently from what we expect. The communities most fascinated and worried by the discovery are those studying interstellar chemistry. If light can travel through or be transformed by materials unknown to us, it could reshape our understanding of how planets form around other stars and how organic molecules evolve. Some propose that 3I/Atlas may contain pre-solar grains older than our Sun, or even remnants of exotic stellar environments like carbon stars or magnetars. But the conversation inevitably touches on speculative territory, not because people want to jump to alien technology, but because the feature, narrowband emission, has historically been associated with engineered systems. Natural objects can produce them, but rarely, and never under conditions this cold and inert. Most astronomers remain grounded. They expect a natural explanation. But the truth is, they don't have one yet. The implications are enormous. If JWST's signal is real and reproducible, it could mean 3I/Atlas contains exotic interstellar minerals. The object is interacting with sunlight in a completely unknown way. Its internal structure supports optical resonance. Non-thermal energy transfer is occurring, or it's part of a class of interstellar objects unlike anything seen before. The next phase is crucial. Webb will attempt to reobserve the object before it becomes too faint. Ground observatories will try synchronized monitoring to determine whether the signal changes with rotation, distance, or solar angle. If the emission persists or evolves, scientists will be forced to rewrite entire sections of interstellar object theory. The most unsettling possibility is that this wasn't a one-time flicker, but the first signature of a behavior that intensifies as the object moves farther from the sun. If the emission grows, shifts, or becomes structured, astronomers will have to confront explanations far outside the standard comet-asteroid paradigm. For now, JWST has delivered a message the scientific world didn't expect. 3I/Atlas may not just be another visitor. It might be the first true glimpse into materials, processes, and physics that exist only in the silent spaces between the stars. The light shouldn't exist, but it does. And until researchers can explain why, the mystery of 3I/Atlas will only deepen.